using this device, the Leap Motion device, what we do is we track hand movement. I can show you a little visualizer. This is how they use to debug it. So what it does is it tracks where your hand movement is, so you can see what you're doing. But using that idea, what I did was I used a thing called Unity Game Engine. It's just a simple game engine. What it does, I can build it quick, show you. I have built-in scripts on all the objects that you can interact with using your hand. What it does is it sends a string down the serial port all the way to the Arduino. It's connected to a PCB. And what it does is it checks which object, so which finger on the hand. So the way the game works is it can check colliders on each finger, bone, hand, all that sort of stuff. Checks which one is in contact, reads in the serial bit there, so whatever I've decided to send to it. Then it turns on the relevant feedback at that point. So if it was the thumb that does it, what it does is it sends a T down there, string, picks up what it was a T, picks it up, turns that on for a split second, checks again. So it'll just keep polling or keep doing it until it does it.
The name of my project is temperature measurement of the candle flame using a CCD camera, and it works by it takes the images of the flame using two different filters with two different wavelengths. Then it processes the images using MATLAB and provides a temperature map like it's shown here. Basically, this is controlled by a stepper motor, which is controlled by this hardware right here. It just takes the image from here, it switches the filters when MATLAB gives the signal through the Arduino, and it just it goes through and the camera takes the image.
Hi, I'm Scott Broadley. This is our MEng final year project. So we were tasked with modernising the existing Snores Plus system that was created here at the university in 1999. So it's a multi-parameter assessment of speech system. So you're measuring various aspects of speech, such as your tongue position, nasal and oral airflow, as well as we were tasked with adding swallowing functionality to that as well.
Okay, this is my robot arm control, and it's been implemented using inverse kinematics project. So the purpose is to pick and place an object through a predetermined path, and as you can see through a little demo. So an X and Y, XZ coordinate has been given, and then the robot arm moves to that particular point, picks up the object, and then goes to the drop-off point.
So basically what we've got is the fatigue monitoring crash helmet system. It's based off sort of 4 sensor systems. We have a gyroscope that monitors the user's head tilt forward and then backwards again. So it's detecting the lean forward when you start to fall asleep. Also got a heart rate monitor which connects to the ear, monitoring reflection coefficient in the ear. Then monitors this against a pulse system and can take an average pulse from the user. Helps determine, basically when you start to fall asleep, your pulse rate lowers, and it's one of the key signs.
So, George, what does this project do?
Well, it's designed to test the oil seals on diesel fuel pumps by applying oscillating pressure frequency, which can be adjusted in both phase, amplitude and frequency, depending on the frequency of the test rig itself.
Tell me what this project's all about.
Okay, so the aim of this project is to produce a PCB circuit design using a 3D printer. So we've got a 3D printing device that prints out the plastic for the base of the PCB, which we then switch over to a second extruder head, which will then print out the tracks of the PCB. And so forming a fully functioning PCB device.
Okay, and then when you put electronic devices down, how do you get those to stay on the board and electrically connect to the board?
We can use something like a cold solder, where we basically use a conductive glue to actually place on the pads, which will then place the component legs on top of it, and that will hold it in place with a good conductive functionality.
Oh, that's brilliant. And then have you looked at profiling the board for electronics that need different heights?
We can, with further work, we can actually look into having the extruder function at different angles to allow for different circuit design and housing design. But with future work, I think that'll be achievable.
Well, it's a really great, really interesting project. And why did you do it, out of curiosity?
Well, we were interested in looking into rapid prototyping for circuit boards, because currently for PCB design we need a lot of other equipment, UV box for the PCB outline. Which then you need a lot of chemicals to actually
but
process.
The smell of the chemicals is a rite of passage for everybody. You're taking it all away now, come on. But I think it's really good.
Brilliant.
Excellent,
Yeah.
well done.
Thank you very much.
That's all right.